Hello there! How are you? Here, let's consider rational expressions as our functions. Our f of x is a rational expression given as x plus 1 all over x minus 1. And our g of x is also a rational expression as 1 over x. And here, we are going to solve for the sum and difference of these two functions. But before we do that, let's be reminded of that our expressions now are rational expressions. Hence, we really need to review how do we operate rational expressions. Let's start with this form. You have f plus g of x. If you have this expression, it means we simply add the two expressions or two functions with rational expressions. So your first is x plus 1 all over x minus 1 to be added with your second function 1 over x. Now, our rational expressions are similar to your fractions. You cannot immediately add nor subtract fractions if they are considered to be dissimilar. Dissimilar in the sense that they don't have the same denominators. Here, our two rational expressions also do not have the same denominators. The first denominator is x minus 1 and the second is just x. Similar to 1/3 and 1/2, we cannot automatically add them, but we can look for a strategy which involves the least common denominator. And here, before we could add 2, we also need to come up with the least common denominator. The least common denominator of 1/3 and 1/2 is when we multiply the denominators 3 and 2. So that's 6. So again, the least common denominator of 1/3 and 1/2 is 6. Similar to this one here, since these are not values or constants, we simply need to multiply x minus 1 and then you have your x. This is the product of your two denominators, which is considered as your least common denominator. To continue, we are going to determine the correct numerators now for our two expressions using the LCD. So we will divide this x minus 1 times x by the denominator of x minus 1. Since we already have x minus 1 here and x minus 1 here, it will be cancelled out. What's left is x. That should be the multiplier of your numerator of your first rational expression, so that we could establish the correct process of adding rational expressions. So again, we are going to divide this with the denominator leaving x. That's the multiplier you need to add, or to multiply rather, in your numerator. Same thing here. We're going to use this and divide by this denominator, removing x. So the x minus 1 is your multiplier to 1. And since it's plus, so we'll use here plus. Again, your multiplier is x minus 1 times your numerator of the second rational expression, 1. So once you're done with that, you simply try to multiply the numerators. Let us not multiply first the denominators, because there might be some things that we could cancel later. Let's check if there is. So when we multiply this, you have x squared, x times x, plus x here. Oops, that's x. Next, you have here 1 times x, so you have plus x, and 1 times negative 1 is minus 1. For your denominator, again, let's stick with the factors in the meantime, times x. Your numerator would be equivalent to x squared plus 2x minus 1 all over this expression, x minus 1 times x. Okay. Now let's see if we could factor our numerator. This is a quadratic trinomial, so let's use here the AC way. AC, you multiply the A, that's 1, times your C, which is negative 1. The value of AC is negative 1. And the factors of negative 1 is 1, negative 1 and 1, and of course, the reverse of it, which is just the same. If we're going to examine these two pairs, and if we're going to add both of them, none of these two will result to positive 2. Because negative 1 plus 1 is 0, as well as here, 0. This would mean our numerator is non-factorable. Okay? Since it's non-factorable, we cannot look for factors. In this case, this is our final answer. Or you could multiply this here, these two, to get your final answer. But let's not multiply them in the meantime because we'll be using the same concern as we subtract the two functions. So again, this would be our final answer for the sum because we can no longer factor our numerator. The next expression is the difference, f minus g of x. So the same thing will happen. You will have x plus 1 over x minus 1. But now we're going to subtract the second rational expression of 1 over x. So the same thing here. You will have the same LCD because we have the same expressions on the denominator. X minus 1 times x. Again, let's not multiply them because there might be, for this case, because we were not able to cancel anything earlier in addition. I don't know if here, let's try to move further. So let's not multiply it yet. So the LCD again, this to be divided by x minus 1, you're leaving with x. So that's the multiplier you need to place for your numerator. But since the operation is subtraction, this is where it gets different from the previous form. Minus, you will have this to be divided by x. So you have x minus 1 as your multiplier with the numerator of 1. Okay? Numerator of 1. So now let's continue with this. We have this expression here. X squared plus x here. Then minus x for this form here. Because you have this 1 times x times negative. So you have that. But negative times negative is positive. So you have plus 1 all over your form of x minus 1 times x. Okay? So when we try to simplify our numerator, you will have x squared, that's 0, plus 1 over x minus 1 times x. Now our numerator is, we have two perfect square terms, x squared and 1. But the operation separating them is plus, so we cannot use the difference of two squares because from the name itself, difference, it should be the operation should be subtraction. So we cannot cancel anything here. So this is also the final form for our difference. But again, as mentioned, if you would like to multiply your denominator, so you'll have here x squared plus 1 here as well, all over. When you multiply that, you will also get x squared minus x. Please do not do that because x squared and x squared are part of different expressions separated with addition or subtraction. You can't do the cancellation law because the complete name of cancellation law is the cancellation law for multiplication. If we are also to examine the result of our addition earlier, we could have x squared plus 2x minus 1 all over the same product of x squared minus x. And again, we cannot do this, we cannot do that because of the same concern. So these are the results for the sum and difference of our functions expressed as rational expressions using the concepts of the previously mentioned topic. That's all for today. You're dismissed. And please do not forget to subscribe now.